So in this section, we are going to study the Kepler's first laws. So Kepler's first law said orbit of the planet should be the elliptical orbit. So we are going to study the ellipse. If a point P moves so that the sum of the distance from the two points F and F dash F prime, both of the focus, is constant, then the curve described by P is called the ellipse. This is the definition of the ellipse. Then we'd like to find out the distance between the two focus. This focus and this focus. So taking the triangles. Then this length is y. This length becomes x minus c. So this distance can be expressed x minus c squared plus y squared. Also you can calculate same ways. This is gonna be square root x plus c squared plus y squared. And the sum of these two lengths have to be the constant. This is the constant is a 2a. So this is a definition of the ellipse. So this might be the equation of the ellipse, but it might be better to use a different formulas. So that's the practice ones. Derive the following equations from the definition of the ellipse. So this is the equations we'd like to derive from the definition. This equation. Here. This is the questions we need to answer. So first of all, we'd like to change these equations. So this can be expressed x plus c squared plus y squared equal 2a minus square root x minus c squared plus y squared. Then take a squares in the both sides. Then x plus c squared plus y squared equal 4a squared plus x minus c squared plus y squared minus 4a square root x minus c squared plus y squared. Then if you look at both sides, y squares appears. Can be cancelled out. Then you should keep calculating. We move these terms into the left hand side. So 4a square root x minus c squared plus y squared equal 4a squared minus 4cx. Then 4 is gonna be cancelled out. Then you could write down the equations. Take a squares. X minus c squared plus y squared. This is gonna be a minus c over ax squared. So it's gonna be a squared plus c squared over a squared x squared minus 2cx. So this is gonna be x squared minus 2cx plus c squared plus y squared. If you look at the left hand side and right hand side, minus 2cx appears in the both sides. Then it's gonna be 1 minus c square over a square x square plus y square equal a square minus c square. So if you divide the a square minus c square, it becomes a square x square over a square plus y square over a square minus c square equal 1. So we have these equations. So if you draw these curves, it's x, y coordinate. If you substitute x equals 0 here, then it's y equal square root a square minus c square. It should cross this point. And the minus square root a square minus c square. And if you substitute y equals 0 here, so plus minus a minus a. So by connecting the curves, you can easily find out ellipse. And this is the position of the focus. It's located at C and the minus C. Okay, so this is the answer to the practice ones. Then instead of using the C, maybe it's better to use eccentricities. Eccentricity is defined using these equations. E equals C over A. So instead of C, you can use the AE. Because from this equation, C equals AE. Then this is the square root. A square minus C squares can be expressed A times square root 1 minus E squares. Then ellipse is changing the new forms. But just in this case, C is changing to AE. Just it's quite easy to derive these equations.